Hey everybody, here we are today. 2.3 Island Biogeography is the topic of today's lesson. So without further ado, let's get into what we need to know about this idea of island biogeography. According to the College Board, we need to be able to describe island biogeography. Easy, simple definition for what it is. Also, describe the role of island biogeography in evolution. So we're going to kind of talk about that, especially later on. Now, the theory of island biogeography. We are actually going to do a lab on this. And by me saying we, I mean I'm probably going to end up doing it, videotaping it, and then you're going to watch me do it, deal with it. But here is what the island biogeography says. It says that an island, obviously in its literal sense, is an area of land surrounded by uninhabitable water. So when we're looking at this, the idea that there are different islands, and now an island can take many different variables to it. It could be close, it can be far from a mainland, it can be large, it can be small, and then anywhere in between that spectrum. Now, depending on those two major factors, size and distance, we can actually look at how colonization rates will look. And then if we look at colonization rates, we can look at how evolution will look. So again, we're looking at how does colonization work, or how likely is an organism to land on said island, survive on the island, and then go on to eventually maybe evolve due to the factors on that island. If you're thinking this sounds very, very similar to Charles Darwin and the Galapagos Island, especially with the Galapagos finches, you're correct. The idea that there was probably one type of ancestral finch that colonized the Galapagos Islands, and then through different reproductive pressures, different mutations, and different evolutionary pressures that are put on those organisms, I've evolved into 13 or more different finch species that have now colonized the Galapagos Islands. That type of one organism evolving into many different organisms is a process called adaptive radiation. And we've seen it happen with many different organisms, but the Galapagos finches is probably the most famous. So let's take a look at how does this island biogeography really matter. Well, what it's saying is, how do species get to the island? Well, we're talking really about things that can get there. So maybe if we're talking about lizards, you're not going to swim there. But maybe they're on like a log or something like that. And after a large storm, maybe a tree gets blown into the ocean, and now it just floats, and those small little lizards or reptiles survive, and eventually it lands up on an island. They swim, they colonize the island, and who knows? Maybe that's how it happens. Birds get blown offshore during a storm, they look for land, and they find it. Now, what is going to influence the rate at which they colonize? Well, how about proximity? The closer an island is to the mainland, the more likely it is that it's going to get colonized. Now, also size. If we were looking at size of an island, independent of distance, size of an island, the bigger an island is, the more likely it is that it will be colonized. So distance, closer is better, and size, bigger is better. So if we want to talk about conservation-based and colonization rates, what we're really looking at is larger islands close will have better colonization rates. Now, take a look at these charts. These charts are standard issue for island biogeography. And what it is saying is that if we look at the first one on the left here, immigration versus extinction, the greater the rate of immigration, the lower the rate of extinction. But less and less organisms coming in, as the number of species increases, you eventually reach this equilibrium number, like the kind of the balance between how many species are coming in, how many are dying off. So that's like your maximum number of diverse species kind of surviving on an island there. Now take a look at the middle one. The middle one is really what we're kind of looking at here in size. So the middle one is looking at size. And what you can see is the larger islands are going to have a higher immigration rate, meaning there's more likely they're going to colonize. And it also has a lower extinction rate due to probably having more resources available. So if we look at the total number of species on the island, The large island, sorry, let me go back here real quick. My pen wasn't activated. The large island will have more species than the small island. Okay, so the number of species, so the biodiversity of a large island will be greater than that of a small island. Now compare the near versus far, the proximity. That's going to be here on chart number 3. A near island is going to have a greater number of species than a far island. Again, it's going to have a greater immigration rate and it's going to have a lower extinction rate because of that proximity to the mainland. So hopefully you're understanding the differences between these and how we can kind of quantify these different charts and how these are kind of very, very common to see when we talk about island biogeography and how different organisms colonize and which ones are more successful for colonization. Here we have Charles Darwin. Hopefully you understand, and I've kind of alluded to this a little bit already, that due to the colonization rate, the ecosystems will have different food sources, different predator ratios, and therefore you're going to have different stressors on the organism's success. All right, it leads to more specialized species that are going to be very uniquely adapted to those habitats, mainly due to the random assortment of organisms that are going to colonize. This results in different realized niches or different roles they have within the ecosystem. It favors diverse organisms or organisms that can kind of adapt to those different characteristics. And over many generations now, mutations will help some. Again, going back and talking about reproductive fitness and the idea that certain organisms are going to have a better chance of survival due to their genome or their evolutionary traits. That is going to help them to survive. They're going to reproduce more frequently, then more likely their offspring will dominate the gene pool, and those traits will continue to thrive. That is the basis of evolution. All right, so hopefully that's not anything new to you. Hopefully you understand it. Now, the big thing about island biogeography is not just actually talking about islands. All right, when we talk about an island, most of you think of some areas surrounded by water. But what if we looked at it from more of a conservation standpoint or looked at it through a different lens? Remember, an island by definition is a habitat surrounded by uninhabitable habitat. So what about like a park in the middle of the city? Now, is it better to have a large centralized park a la New York City? Or is it better to have many smaller parks like Philadelphia? So this is a different type of look and different type of approach to island biogeography. This is something that goes into the idea of urban planning and how do you develop a society? How do you develop a park system with or a network of park systems? Or how do you develop certain wildlife refuges based on the habitats surrounding? And then you also want to look at how close in proximity you are to other parks. Remember, proximity and size matter. So, at the end, in conclusion, for when we're talking about island biogeography, do you understand and can you describe the definition of island biogeography, the idea of different colonization rates and the rates in which organisms survive? Do you know the big two factors? Proximity, how close or far, and size, large or small. Right? Do you know how they influence colonization rates? Now, do you know what would be the perfect scenario? Having a large island very, very close or small island very, very far away? Hopefully you'll be able to answer that. All right. I have a feeling you did pretty well understanding this stuff. I have a feeling it's not really too confusing. And I have a feeling you're just as excited as I am to see the next unit. So I'm looking forward to seeing you at the next lesson. Have a good one.
You like that lesson? I know you did. So why don't you go ahead and smash that like button right now. Go ahead and comment. Tell all your friends about how great that lesson was. And make sure you subscribe, because I'm going to keep bringing you AP environmental content that you're going to want to watch. Or do whatever else those other YouTube channels tell you to do. And with that, Maloney, out.